Hey guys, so I'm going to be talking about electric fields today. So, in physics, a field is a region in which a force can exert its influence. When we talk of electric fields, it's a region in which an electric charge can exert its influence. Say we have a positive charge, a proton for example here, can exert its influence anywhere around it. I'm going to show its electric field like this with arrows with these lines emerging from it. Now, in physics, it's taken that an electric field originates from a positive charge. The same way we deal with things in a battery. Charges go from positive to negative, the conventional flow. The same applies for static electricity when we're talking about our electric fields. So we assume that, or rather we say that, the electric field, but not really the electric field, but the arrows of the electric field originate from this positive charge. So the arrows point outwards from the positive to the negative. Yeah, that's what I meant. From the positive to the negative. So positive charge like that. Then my negative charge, the arrows go to the negative from the positive to the negative. Yeah. This is one thing you should take note of. Positive charge, arrows go outwards. Negative charge, arrows go inwards. Because the the charges, as in air quotes, the charges go from positive to negative. Yeah, the electric field goes from positive to negative. That's its direction. So now let's look at how particles and their electric fields interact. So there are only three possibilities. Rather, actually two actually, but we talk of three. You're going to have a proton and a proton, a positive charge, and its fellow positive charge. This is like charges, and you know like charges repel. So we expect these two to repel. What's going to happen is this one's electric field is like that, the same thing we drew. This one's electric field is like that. But there's going to be interaction between this side of the electric field. So here, because these two are actually have the same charge, they don't want to be next to each other. They're going to repel. So the arrows that were supposed to go here will be curved to avoid the arrows of this one. So it's supposed to be like this, right? Like that. But then these have like charges, so they don't want this situation where the electric fields are touching like that. So instead, what will happen is that they will curve away from each other. Not I'm going to have this situation like this. This curves away, 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 this curves away. There's going to be a neutral line somewhere. This is how positive charges interact. The same applies for negative charges interacting, except the arrows point inwards, and this will be a negative sign. So let's look at it. Negative charges. They're still like, just different charge. So negative, negative. How would they interact? Remember, the arrows go to the negative. In this region, in between the charges, the electric fields do not want to interact, or rather, they don't want to come into contact. So my lines will curve like that. Because they do not want to come into contact with this one's lines. And we have that neutral line. The case is different when we have this, when we have unlike charges. A proton here and an electron here. Positive charge, negative charge rather. So remember I said the direction is from positive to negative. Here it's gonna go away like that. Away like that. Like that. And this one into to the negative. To the negative. To the negative. This shouldn't touch there. Rather something like that. To the negative. So now this goes like that. There's attraction between these two. Like that. They should touch on individual points on the electron and the proton, but well, you get the idea. There's going to be attraction between this positive and that negative. That's why the electric fields interact like that. So, key points. If you have like charges, the electric field diagram looks like this. If you have unlike charges, it looks like this. If you have a positive charge, the arrows go outwards. If you have a negative charge, the arrows go inwards.